Deze podcast is powered by ACC ICT, de nummer 1 Kubernetes specialist van Nederland.
Welkom bij een nieuwe aflevering van de Nederlandse Kubernetes Podcast. De podcast over Kubernetes voor iedereen. Ik ben Ronald Kers en ik zit, zoals altijd, sta trouwens, met...
Ja, we staan een beetje. Hallo Ronald.
Jan Stomphorst, Solutions Architect bij ACC ICT.
Hey, het is altijd wel lollig. Ik moet weer wat nieuws verzinnen. Maar nog steeds, TechEX, nog steeds in het witte hokje.
Witte hokje inderdaad, ja.
En nog steeds rumoerig.
Ja, heb je het naar je zin?
Ja, heel leuk.
Nou, ik ook.
Nou, mooi.
En we hebben weer een gast gevonden.
Nou, dat is
Ze hadden op hun stand Kubernetes staan, dus dan moeten we natuurlijk wel de podcast in hebben. So, I would like to introduce Skotnický. I butchered that almost. Yeah. Please correct me because...
Yeah, okay, so hi guys, I'm Adam Skotnický, right? And I didn't understand anything you said except of Kubernetes, so but that's good. That's, I think, good spot for me as I work with Kubernetes for a long time.
Okay.
And I started in basically completely at the beginning because that time we worked with OpenStack quite a lot. And we had friends in different companies like Google and PayPal and eBay. And they told us one day, guys, there's the new thing Google released. They just released it to public. It's called Kubernetes. What do you take a look? But at that time, Kubernetes was the true self, right? Stateless, nothing special, like really sleek, small, clean design. But of course, now it's like enterprise tool with thousands of different configurations and variations, which make this beast which we have today. So yeah, I work with Kubernetes quite a lot.
Okay, and how did you get started in the IT? What is your background?
Yeah, I started in 2010 as a data center architect. And we built 1 megawatt data center for cloud technologies in Czech Republic. And when we finished, I said, Adam, it would be great if we also had some cloud technologies in the data center, right? So I started with the cloud technologies, and we started with OpenStack, long story short, and then we spin off that company as a separate company called TCP Cloud. 2016, we sold it to Mirantis in US. And we worked with Mirantis, and in Mirantis, we work on quite large deployments. Thousands of servers even in a single cluster. So yeah, very interesting. And at that time we already worked with Kubernetes too. We internally ported OpenStack to Kubernetes as a host. And then later I quit Mirantis and I started this company which is focused on Kubernetes solely and especially the management on top of Kubernetes and how to effectively deploy it, manage it, do the applications, the ecosystem, right? Because people think that Kubernetes is one thing, right? It's simple to deploy Kubernetes, right? It's easy to deploy, it's super easy, but it's just ecosystem piece, right? And if you don't have the monitoring, backup, management, and segmentation, and life cycle, you will be lost, in a few months, and then you need to do it again, right? And this is why people sometimes say Kubernetes is too complex because you need to. There's a lot of things you need to learn.
Yeah, you can make it as complex as you want.
Yeah. And that's the biggest issue because there's thousands tools you can have, and people like to cherry pick. I like this idea, I like that idea, I like this tool, but everything needs to work together. And yes, and again, that's what we try to do. So we try to make Kubernetes invisible. That's how we define it.
Okay, how do you do that then?
So we built a platform around it called Taikun.cloud. That's the name of the product. It's run as a SaaS tool, so you can just log inside in Taikun.cloud and connect your infrastructure providers like public clouds, hyperscalers, or also your private clouds, like OpenStack, for example, I mentioned already. But you can use VMware or you can use whatever you want. We also support a virtualization layer, like just pure vCenter or Proxmox, or even some edge stuff like Zadara, Zadida, where you can have thousands of small nodes where you can deploy dynamically Kubernetes through us too. And we try to do the decisions for people, right? Opinionated way means, right? So we deploy Kubernetes dynamically, and we will ask you only a few questions, like how much resources you want to give it, right? What version of Kubernetes you want? Do you want to have monitoring or not? Do you want to have backup or not? But this is like the we try to limit what you can do, right? We will not generate the configuration file for you which you can edit. You will never see this file, right? Because if you will see this file, you will edit it and then you will break everything else, right? And we continue inside, right? So I mentioned monitoring and backup, but we also do ingress, right? So we preset the ingress for you based on the environment you are, so it works.
You don't have any choices. You've got an ingress for...
Yeah, so our billing model is based on management, resources under management. So CPU and RAM under management you have per hour, pay as you go. But we work with enterprises too, and they want to have fixed model. So that's basically limit how much resources you can manage in Taikun in one time. So this is the thing. But we don't have any other charges. We don't have like feature-based charges. Like if you want to have ingress, you pay more. If you want to have load balancing, you pay more. If you want to have...
Do you have choice in a specific ingress, or you don't? Are you only support one ingress?
We call this Taikun ingress, but it's Nginx. But why it's there? It's because part of the environment, right? So if you, for example, because we also support application deployment, right? So we using Artifactory Hub Mirror of the official Helm charts.
Yeah.
And you have it already there. You can create custom catalogs. You can edit the parameters. You can expose only parameters you want to your end users. Doesn't matter if it's internal developers or your outside customers. So they can only deploy only specific parameters. They can change from the whole Helm chart only 2 parameters you want them, right? Like password and user or endpoint or something like that. And that's why we created Kubernetes for the Helm chart to automatically sit there, because the Helm charts expect that there will be things, right? That load balancer will work, that the ingress will be there, right? That PVCs will be available, and that's what we automatically level the features between all the providers to work, and you also guarantee that whatever you deploy anywhere, we can move to any other location. So if you have AWS deployment, you can move it to your Proxmox under the table, and it will work because Proxmox doesn't have load balancers, right? So we dynamically provision Taikun load balancers to mimic the feature, right? And we have all the defaults set, so it will just work, right? That's the idea. So this is invisible Kubernetes. It means that we have everything in already.
What kind of CNI you use?
We're using Calico, but we will probably switch it to Cilium because it's more Kubernetes supported now. Everybody loves Cilium, so we will do Cilium. But the only reason we would like to do it is because Cilium has better multi-cluster networking capabilities, which is heavily requested by customers and by users, but not really used in the right?
No, why? I wouldn't use it.
Yeah. The multi-cluster
It's stupid, but
yeah. So that's again, I think the same thing, but I know if I can say it aloud, yeah. I think the problem is that even Cilium multi-cluster networking expects that you somehow manage the workload on top, right? So it should know that it's in different cluster, right? So you still need to do this. And also you need to provide the transport, right? So it will not solve the transport issue for you. So you still need to have even if you have 2 clusters, and one you have under the table in Proxmox.
Yeah.
And one it's in AWS and US, right? You need to provide the transport between these two.
And you've got latency and you've got all those fun things.
Yeah, so it's requested. So that's the only reason why we would switch it. But we are pretty happy with Calico. It has pretty good EPAM. It's pretty good airbag. It's used for a long time, stable, right, between versions. So, but there will be options. You will be able to, we have something which we call Kubernetes profile, where you can tune a little bit how the Kubernetes will behave. So you will be able to choose between Cilium and Calico. But we have this because sometimes when you want to land Kubernetes somewhere, and especially if it's a private location, you, for example, have proxies, right? Or you have different DNS stuff, and Kubernetes heavily depends on these. So you sometimes, if you have a segregated location, that's why we have these profiles. So it still work, right? Because our ultimate goal is that the Kubernetes, when you hit the deploy, it will work and everything on top will work.
So it deploys also Kubernetes, your product?
Yes.
Okay. And it deploys it on in all clouds? And on the cloud, do you use then ACAS or,
No.
or it just uses machines?
Yes.
How do you solve storage?
So again, options. So if you have clouds like AWS and others, we will always create the default storage class for you. based on the location, right? So you can choose when you're registering the endpoint, for example, for AWS, you can choose if you want to use GPT-3 or what you want to use, and that will be locked for that cloud credential, right? So when you're spinning Kubernetes clusters from this cloud credential, we will automatically decide the storage, and it will be there. Yeah, for all balances is there. So we know you want to install it to AWS, so we will install the AWS controller, so your PVCs and load balancers. We will rename the storage class to be default or everything, so you don't need to, when you want to move your workload from location to location, you don't need to change the parameters and things like this. So yeah, that's what we do. And if it's on-prem or if it's like devices like Proxmox or Edge, where you don't have any storage provider, you can choose. We will automatically deploy Longhorn or NFS. So you can choose if you want to have NFS for non-HA dev location. If you're a single device, make no sense to deploy Longhorn, right? Yeah, it's much better to have just an NFS provider. So we will deploy dynamically.
But
NFS.
Longhorn is only RWO. Has no RWX connection.
Yeah.
How do you do that then?
Yes, and then
So for you, RWX is
Read write only.
the other one. Is WX is that two machines can connect to the
Connect to the same point.
storage. So two nodes can connect to the same storage.
Yeah.
And if you have RWO, only one machine can connect to that storage.
Stop ice quasi.
So no, that is important. It's not exactly how this is not the issue. The issue is write-read, right? So it's file system issue, in fact. It's not block issue, right? So it's file system issue. So the difference between this is only if the file system supports the fencing, which NFS does, right? So that works.
NFS is no problem.
Yeah. So it doesn't. But in reality, it's not a good idea to use this because this is old clustering issue, right? To write in the same file system folder, right? But that's what you're doing.
Yeah, but you've got applications like a web server. It needs to write something to one file system. And you've got replicas of that, and you want those replicas
To have same data. Yeah.
same data across more than one node.
Yes, that's why we have the applications. So if you have something which requires that, we have in applications, you still have the NFS option, you have this option, so you can choose this. But if you want to have HA option for that, you can choose different ones. Like theoretically for web server, you using object, right? Not file system approach. But so you can use, for example, Menil, or you can hook up any other stuff we support in applications, which is any Helm chart, because you can import also your Helm charts, so you can do whatever you want from this regards. And how we do it is that we have this multi-tenant approach, where you log inside, and if you're a partner, you have organizations, and the organizations have managers and they have users. So why we segment it this way? Because you have cloud service providers or internal companies, or even if you have a really small team, you have 5 guys, right? And probably out of these 5 guys, you sacrifice 1 guy to manage Kubernetes, right? In this team.
Yeah.
And that guy is someone we call manager. It decides for other guys how they will consume the Kubernetes cluster, right? The setups limit, can tune these profiles, who can, we have access profile, alerting profile, where the alerts will route from the Kubernetes cluster, who can SSH into the nodes, and with what role, who can Kubernetes, how it look like, what storage you will use or not, if you want to have something other than default we have. And then we have users, and again, it's not like users, it's technical users, and they are only care about, I have this I have this kubeconfig, or I have this application catalog, and I want to deploy this, all good reference to WordPress, right? Because this is a web server database, right? So I want to deploy this, and I only care about this be running, and I want the endpoint, right? I don't care about Kubernetes. In reality, nobody cares about Kubernetes except of the platform engineers.
Yeah.
Right. So that's how we segment it, and then we have the partner who can have multiple of these organizations under them, and also pre-decide some of these things, right? What cloud credentials you can access. They can be preset, so you don't need to register your own, right? They can provide this for you and so on. So that's why we create this structure. So we're trying to, again, continue this invisible Kubernetes, also not just because during this process, we realized it's not technical issue, it's management issue, right? Because the Kubernetes itself, it's complex and dynamic and everything, but even even Kubespray, if you deploy Kubespray, it's pretty clean, right?
Yeah.
There's not thousands of stuff.
Yep.
The problem is that the first guy who will come and start installing the other stuff, that's the problem, because that will lock it for a long time back, like CRDs and custom CRDs. You will deploy there and operators, and then these things. These things make this complex. It's workload related and it's opinion which you exert on the Kubernetes, and that's what we are trying to remove, right? Like, don't allow you to do that. You can still do it. You can override us anytime you want, and you can just say no, I will do it my way, right? But if you want support from us again after that, we have repair button, and if you do the repair button, we will all the state back.
Yeah, that's cool. And if I have my own application, do I put it in your cloud also, or in the application?
So you can. We have mirror of Artifact Hub. Not all of it. You know Artifact Hub?
Yeah.
Right. It's like go-to store for Helm charts, right? So we mirror the official ones because they are somehow secure or safe. We don't mirror the user ones, but we can add because we don't directly use Artifact Hub. We have mirror, right, which we control. So we can add your applications, which if you want to offer them through us, you can do this. Or you have private Helm import, right? So you can import to your own project anything you want, any application you want.
And do you, because if I'm a simple user, Helm is pretty difficult also. Do you add something like pod disruption policies or
So we have
priorities or?
So if a single container we will run to run, right? That's the question we had. So we create something which we call simple app Helm chart.
Mhm.
When and you are just developer, you build your first Docker container, you would like to run it, right? So what we do is that you go to this simple app. You will basically click I want this. You click next, and it will ask you what is the repository and point to your Docker container. What is the Docker container you want? And then there's some options like, do you want to have PVC with this? Do you want to expose this through ingress? Do you want to, we have this like basically options you can use, and then you just hit install, and then you end up with a pretty good Helm chart even without the Helm chart, right? So that's how we managed to don't have more complex solution, because we didn't want to add some extra other API layer to onboard this. So we're still keeping this Helm chart because Helm chart is good. It's pretty flexible, right? And we support auto syncs and things like that around Helm chart management. So we keep this, but we bring the simplicity by you really can go to our UI and click next, install, and you will end up with the exposed application, even with a single container.
Okay, that's cool. And can I then use my Git repository to import that Helm chart and do something with the API special things, or just pull requests from my pipeline? And
Yeah, sure, of course. Like, first, you can import from your Helm chart from your repositories. That's important, even from your private ones. But I talk about UI. But we have, of course, Terraform provider, we have Crosspoint provider, we have Go CLI build we can use for the pipelines, right? We have REST API you can use. You can generate API token, of course, and then if you want to really go deep. But our API is pretty complex because we do basically everything from the virtual machine deployment up to the application deployment. So we have something which we called like decisions.
yeah,
Where if you take, like, you would expect that our Terraform file will be pretty complex, but it's really smooth. It's really small and very smooth, because to deploy Kubernetes cluster is 4 lines, right? With all the decisions.
oh, that's cool.
If to deploy applications, depend on how many parameters you would like to rewrite, 4 lines, right? Into this Kubernetes cluster. And we, of course, for example, now with Loft, we have, by the way, we have common web, what is it called? Like, not webcast, doesn't matter. We have just presentation together with them. Do you know Loft, right? Virtual clusters. So we now support virtual clusters, right? So you can single click deploy or single Terraform call deploy virtual cluster to existing Kubernetes cluster and deploy applications into it, right? So and that's a better idea, because as you know, CRDs, for example, it's really difficult in single Kubernetes cluster have multiple same CRDs, right? Versions of it.
Yeah.
Right. So if you have one Prometheus and you would like to deploy another Prometheus, there will be clash, right?
Yeah.
So if you have virtual clusters, you can deploy as many of these versions you want, same versions, different versions, and same Kubernetes clusters get segregated. So that's what we like. So we onboard that you can have bare metal Kubernetes cluster, virtual Kubernetes cluster, AKS, whatever else. You can import it to us, and you can single-click deploy virtual clusters inside to get applications, right? And then you can host in the same Kubernetes cluster. You can segment it to as many as you want with the same application used. So, and that's pretty powerful in the Kubernetes world because, again, it's Kubernetes and Kubernetes ultimately, but that solves sort of issue with the CRDs and versioning and upgrading stuff because you can keep the underlying Kubernetes pretty clean, and you can have your special stuff in the virtual clusters.
So a lot of things I've heard before. For example, at Rancher.
Yeah.
Can you explain the difference between you and Rancher, or maybe even Omni from Sindero?
Yeah, so Rancher is simpler for me. I know we know Rancher pretty well. So Rancher, the major difference is that you need to manage your Rancher, right? You need to deploy it. Of course, you can have the Rancher in AWS or somewhere, but in general, you need to deploy it, and you have your own instance of that, which has its own version and all management and everything. And we don't have that. We are SaaS platform, so you can use us from cloud. You just log in, give us access to the cloud, and then we're done. No installation, no versioning, no upgrades, nothing like. We do this for you because this is SaaS. Of course, if you're enterprise, you can have an instance of Taikun on-prem, your own private version, but we provide the same service, right? We keeping it alive and we do the management. So this is the major differences in the strategy, and also from the strategy how we manage and deploy the Kubernetes clusters. We do this everything agentless, so we don't have anything inside. We everything do from outside, right? So all of this management I described, we call this global controller Taikun. It's our custom code. It's not open source or anything like that. But all the Kubernetes clusters we deploy or manage are fully open source. Plus all we deploy inside, the monitoring, backup, the ingresses, everything is fully open source, right? So that's
even the observability part.
Yes, everything's fully open source. The community products are pretty good. It's just about that you need someone who knows them, right? And that's what you're paying. We're paying usually for the people who know, this version is, maybe we'll skip that. Or here we need to change something. And that's what we provide through the Taikun. We provide this managed experience to the open source clusters. So
you manage the clusters also, upgrades, updates, and all the
full life cycle, auto scaling, everything. Yeah.
And what if you just said it? I have an application and it's pretty stateful, really stateful, and you're gonna update.
Yeah.
What happens then?
You mean upgrade the cluster?
Oh yeah, I'm not managing the cluster. You're managing the cluster, so I want my application to running.
Yeah. So we do rolling upgrade, and we have some pre-flight checks, like to provide some better experience. Of course, it's not completely 100% foolproof, right? So what we do is that we will tell you what you need to change or what you will experience if you will go through this, right? So if you have a small cluster, you will check if you have enough resources to do the rolling upgrade. And you go, if you want to upgrade, you need more resources. So you need to add more node if you want to upgrade, right? That's the first thing we check. Is there enough resources to even do this? Then second thing is, are we able to do the upgrade? Because you can have PDBs and other working resources inside, right? Which can, I don't know if you mean the stateful by that, but
stateful.
Yeah. So we tell guys, sorry, you have these specific PDBs which blocks the upgrade. So you need to deal with them. You need to remove them or change them. Otherwise, we cannot do the upgrade because even the rolling upgrade needs to do the drain, right?
Yeah, of course.
So that's how we approach this. It's not like magical, but it's close enough where there's at least some expectation that something will happen, right? So there's some communication, but needs to be done. If you have situation like you described, where you have really stateful thing which cannot be restarted or the pod scale.
In my experience, a lot of customers have stateful things.
Yeah.
It's just really difficult to make stateless applications.
Yeah. 90% have stateful. But to be honest, most of the things doesn't mind if they are restarted, right? very minor interruptions. So yeah, you should do it in some maintenance window or something like that. But only once happened that we didn't upgrade in the past 3 years, because we run this 3 years already. We for like first 1.5, 2 years we did it only for specific customers we know. So we developed a little bit on them, right? And then now it's public for a year, and it's rare that we will not be able to upgrade because. But it's true that it's not like that you have 100% availability through the upgrade. There is restarts, right, of stuff.
Yeah, of course.
But the same for databases also.
Yeah, but the database, if you have database which is single nodes, right? Sure, right? It will die. But usually, that's why you have Kubernetes, right? It's pretty easy with Postgre operator or something like that. The database which is not single node. Right?
So, thinking about, are you only doing Kubernetes? What if I don't want a database in my cluster?
It's up to you. You don't block anything. You can.
Then I have to do myself.
Yeah, sure. Like if you have RDS and you want to use, you're using us and you have RDS. Like we don't block it anyway. It will work.
Of course, but if it's not in your platform, you're only doing Kubernetes.
Yeah, we do the cloud native thing. So if we will help you if it's inside. If whatever it's outside, we don't have access to. We don't know about, right? So you can.
So it's also
we don't know.
Sounds like a little bit like OpenShift, what Red Hat does, or
yeah, but OpenShift is so first OpenShift architecture is single Kubernetes cluster, right? So we are not single Kubernetes cluster, right? We are a controller which is outside of the Kubernetes cluster. OpenShift is tied with the Kubernetes cluster where it's running, right? So this is the coupled, right? So our control is some outside. So we deploy Kubernetes cluster. So it's like if OpenShift would deploy other OpenShifts.
all right.
Right, which also exists. By the way, when you give us access to OpenShift, what we do is that we deploy OpenShift in OpenShift, because the biggest issue with OpenShift is that you have single Kubernetes cluster where you basically have all of the stuff. Usually, it's also bare metal OpenShift pretty often. So you have all of your stuff, all of the workload to deploy it, and now you need to upgrade it all at once, or you want to do changes. So that the clash is there's huge clashes inside. So to move OpenShift from something to something, even change configuration, it's not about upgrade, right? It's pretty difficult, and that's because it's monolithic architecture. It seems weird that Kubernetes could be monolithic, but it's not monolithic from the Kubernetes perspective. It's monolithic from the architecture of how control plane is tied to the execution engine or the compute itself, right?
Right.
So we have this decoupled.
Okay, cool. Okay, before we go to the last question, Taikun, is that a nice spelling on the word tycoon, or where does it come from?
Yes, story. So I like if the brands have some story, right? So there's a story, right? So Taikun is it's etymology. From etymology point of view, the US word or the English word tycoon, which the magnate, the guy who managed stuff and have this all this well, it's coming from this Japanese word taikun. It's just for supreme commander, right? And that's a little bit what we do, right? We are supreme commander. We manage all of this stuff underneath of us, right? So that's what it is. But also there's a reference to Taikun games, right? Like so
Exactly. That's what it was going, yeah.
So this is the combination of it because that's my favorite games from the
The roller coaster balloons.
and what are you doing there? You manage your stuff, right? And you
World management.
and you want it to work and you want to be efficient, right? And expand it and change and upgrade, right? And so that's the story of that.
Okay, nice. Cool. So our final question is always, how do you see the future of Kubernetes? This table is a little bit too small to put on a crystal ball, but how do you see the future, or how would you like to see the future of Kubernetes?
So I have pretty different point of view on what Kubernetes is.
Nice.
Right? Because from my point of view, this is API integration platform, right? That's what it is, right?
Yeah.
That's why you do the CRDs and operators and everything. Because you have single, infrastructure, almighty integration layer where you can really easily distribute your workload and call it same way, right? And you can have the same tools, everything. So that's what I see it, and that's how it's used in general, right? That's the biggest power of Kubernetes.
Yeah.
Is that it's extendable API layer which you're using through Kubernetes to manage anything basically you want. Your own application, infrastructure application, databases, storages, everything's there. Monitoring, networking, everything's there under one API. And that's the biggest biggest benefit of Kubernetes. And I think that's what it should be. And so I think it will be the supreme commander of all of the infrastructure you will need in the end, right? That's what it is. It's control API to do whatever you want on top of anything, right?
Anything.
Yeah.
Okay.
So, and that's what we try to do, on top of it, to help Kubernetes to, be that on these devices and to run and control and manage this connections between different Kubernetes clusters. So you can, from central place, have your Kubernetes in your, as you said, like as I said before, like the one single server somewhere to 10,000 edge nodes to your core data center with 100 physical nodes where you're running your heavy stuff. And you can still control it in the same place for all of your users. And doesn't matter if it's external, internal. So that's what we want to do. That's our vision, is that Kubernetes is control layer of everything. And we're helping to manage that control layer of everything.
Cool.
Nice.
Right. Nice vision. Nice vision.
Okay. Well, Adam, thank you very much for joining us so spontaneously in our podcast. And we're going to follow the development of the Taikun very closely and hope to talk to you in the future.
Thanks, you guys.
Okay. See ya.
Bye.